Hello student, in this video we are going to discuss about test signals in transient response analysis or time response analysis. Okay, so we discusses that we are having two types of analysis. First one is transient analysis and second one is steady state analysis. When we are doing transient analysis, we need to know about the test signal. Okay, so we know the test signal are impulse signal, step signal, ramp signal, parabolic signal. So these are the best test signal you are having. So in the topic of signaling system also we have discussed that the impulse and step signal. Okay, so here we are adding two more signal, that is ramp signal and parabolic signal as test signal. The characteristics of this test signal are they undergo certain shock, certain change, and they are having a constant velocity, a constant acceleration. So these are the characteristics of the test signal. So certain change, certain shock, having constant velocity and constant acceleration, these four are the characteristics of this test signal. So the characteristics of actual input signal are a sudden shock, a sudden change, a constant velocity and constant acceleration. The dynamic behavior of a system is therefore judged and compared under application of standard test signals. Test signals are an impulse signal, a step signal, a constant velocity means ramp signal, and constant acceleration means parabolic signal. Okay, and the other standard signal of great importance is a sinusoidal signal. Okay, so coming to this signal, we are having first one is impulse signal. So we know the definition of this impulse signal. Okay, so what is impulse signal? Impulse signal is always represented by del t. Okay, so del t equal to a at t equal to 0 and otherwise 0 at t not equal to 0. Okay, so this del t is nothing but a impulse at t equal. So the definition of impulse signal is represented by del t, and this del t is nothing but a impulse at t equal to 0. So this impulse signal with amplitude, if this impulse signal have amplitude 1, then this del t equal to 1. That means this is called unit impulse signal. Okay. So the structure of image of this impulse signal will be like this. Will be like this here. See, at t equal to 0, it have amplitude a. Okay, and t not equal to 0, this del t equal to 0. Okay. Now coming to the step signal. Sometimes we call this step signal as unit step signal whenever amplitude is equivalent to unity. Okay, here I am calling it as a just step signal. When I am calling it as a just step signal, we need to consider an amplitude or any voltage. So here I am going to represent it by ut, and this ut is equivalent to a at t greater or equal to 0 or 0 at t less or equal to t less than 0. Okay, so this is the definition for step test signal. So when we call it as unit step signal, then this a equal to 1. So diagrammatic representation of this step signal is like this. Okay, so this is ut, this is ut, this is ut. Okay, so amplitude ut equal to a, and this a amplitude is equal to 1. Okay, so this is called unit step signal. So this amplitude 1 at t greater or equal to 0. So it will, at t greater or equal to 0, it will give an amplitude. But if we consider below 0, below t equal to 0, then we are not going to get anything. Okay. Now coming to ramp signal. Okay. So always we represent this ramp signal by r of t. So the definition of r of t equal to at t greater or equal to 0 and 0 at t less than 0. Okay. This is the definition of ramp signal. The structure of image of ramp signal will be this. So when t greater or equivalent to 0, we are having signal like this. This is increasing linearly with respect to time. Okay. So when value a equal to 1, this is called unit ramp signal. Okay. So this is the definition of ramp signal. Now come to the another text signal. This is parabolic signal. Okay, so I am going to represent this parabolic signal by p of t. Okay, so here the definition of p of t is equal to, p of t is equivalent to at square by 2 at t greater or equal to 0 and pt equal to 0 at t less than 0. Okay, so if your parabola having some amplitude, then this p of t equal to at square by 2 at t greater or equal to 0. So this is the definition of test signal parabola. When we can say this is unit parabola, means a equal to 1. Okay, so the shape of this parabola will be like this. So how we will get this shape? This means this signal, this means this signal, this parabolic signal, then step signal, then ramp signal or impulse signal. How we will get this type of structure? So you just you just take these values of t, and you just substitute this t value in the graph. Okay, and you will get some point with respect to x-axis and join the point and you get this shape. Okay, so these are the definition of the standard 4-step signal. Okay, now we will discuss about the relation between this test signal. Okay, so before discussing relation of this test signal, I want to consider S domain. That means transform of the signal. Okay, so see, if we do the Laplace transform of this impulse function, then we will get A. If A equal to 1, then this transform is equal to 1. Okay, now if we do the Laplace transform of step signal, then Laplace transform of step signal equal to A by S. Okay, so if your step signal is unit step signal, then this is equal to 1 by S. Okay, and now what about ramp signal? If we want to do the Laplace transform of ramp signal, then Laplace transform of this ramp signal is a by s square. Okay, so if your ramp signal is unit ramp, then this a equal to 1, then the Laplace transform of ramp signal, unit ramp signal, is 1 by s square. Same for parabolic signal. Okay, so for parabolic signal, if you want to do Laplace transform of this parabolic signal, then the Laplace transform of this parabolic signal is a by s cube, and if your parabola is unit parabola, then the Laplace transform of this unit parabola is equal to a by s cube. Okay, now coming to the relation between standard test signal. Okay, so we know impulse is nothing but del of t. Okay, so if we consider integration of del of t, then we are going to get u of t. So integration of del of t is always equivalent to u of t, and if we are going to integrate u of t, then we are going to get r of t, and if we consider the integration of r of t, then we are going to get p of t. Okay, so by this equation, if we want to get r of t, then what we will do? We differentiate this p of t, then we will get r of t. And if we want to get u of t, so what we will do? We differentiate this r of t with respect to t, then we will get u of t. And if we want to find del of t, then what we will do? We differentiate this u of t, then we will find del of t. Okay, so this is the relation between standard test signal. So student, today I will stop here.